So remember how back in chapter 5 we discovered that we could graph absolute value equations? This idea that I could make a table and I could plug these x's in to this equation where y equals the absolute value of x. So when x is -7, well, the absolute value of -7 was 7. And the absolute value of -5 was 5. And the absolute value of -2 was 2. 0. Absolute value of 2 is 2. Absolute value of 5 is 5. And absolute value of 7 is 7. So it creates a graph that looks like this when I plot these points. Because all of my y values are positive, they're all in this upper area where everything is positive, because my function y is simply a result of taking the absolute value of x. So when x is -5, down here, my y value is 5. And when x is +5, my y value is again 5. So when I have absolute value functions, I end up with V-shaped graph. So absolute value functions equal V graphs. Now, if I ended up taking the negative absolute value of x, I'd be doing the opposite, because the absolute value of -7 was 7, but if it's now negative, my y value is now negative. And same thing down here. The absolute value of -5 was 5, but if my function says I'd then take it in the negative, then it looks like this. Let's skip down here. The absolute value of +2 is 2, but I want the negative of that, so it's -2, and -5, and -7, because the absolute value of 5 is 5, but I want the negative of it. I'm going to end up with a graph that looks exactly the opposite. It looks like this. So negative absolute value, a situation where I have something like this, ends up producing a graph that looks something like this. Now, you can end up shrinking your graphs. So maybe you have a really tight slope. Or maybe I end up shifting it down. The reason I mention that is because in this lesson, you're going to learn to graph by translation. So what is a translation? You need to have this definition down. A translation of a graph is simply a shift. I'm shifting my graph some direction. It's a shift of a graph, and it can go horizontally, it can shift vertically, or it can do both. The result is the same as my initial graph, but my graph ends up shifted into a different position. Let's look at some examples. All right, so let's look at this graph here. Notice in this graph, I'm graphing the equation y equals the absolute value of x. Well, for something like this, again, I want to refer back to my table. So I'm going to make a table of x values and a table of y values. And if I'm looking at these, if I plug -5 into my equation here, I get what? The absolute value of -5 is 5. Absolute value of -2 is 2. 0, well, that's 0. The absolute value of 2 is 2. And the absolute value of 5 is 5. So when I plot these, 0 is 0, 1 is 1, 2 is 2. Over here, -1 is 1, -2 is 2. -5 is 5. So I get this V-shaped graph because it's the absolute value, and all of my y values here are positive, so they're in this area of my graph. Let's look at what happens when I shift it up by 2. What I'm doing here is I'm adding 2 to my y values. So looking at this table, when x is -5, what is my new y value? Well, hopefully you recognize that it's 5 plus 2, or 7. So when x is -5, down here, I'm going to end up moving up to a -7 on my y graph. And when x is -2, I'm going to end up taking the absolute value of -2 and adding 2, which ends up equaling 4. Okay, so find -2, let's plot 4. That's right here. When x is 0, well, the absolute value of 0 is 0, but I'm still adding 2 to it. So it's 2. Okay, let's think about this for a second. What do you think the rest of these points are going to be? Hopefully you have something that looks just like this, where I've got a V shape, but instead of starting with my origin over here at 0, I took this equation and I shifted it up to 2 over here. It's still all of the same points. It has the exact same slope on either side. It's just been shifted up. So when I add or subtract something to my function, I'm going to shift it vertically, one direction or the other. Okay, let's look at a different form of translation. All right, let's look at some of these functions. Let's say I take the function y equals the absolute value of x minus 3. How is this one going to translate? Well, let's look at a table of values. If I plug -3 into my x, then I'm going to end up with -3 minus 3 and take the absolute value of that, which is like taking the absolute value of -6, which is 6. Okay, what if I do -2? Well, the absolute value of -2 minus 3 is the absolute value of -5, or 5. If I do -1, it's -1 minus 3, which equals -4, and it's an absolute value, so it's just simply 4. The absolute value of x of 0 minus 3 is the absolute value of -3, which is just 3. So let's look at plotting these so far. So what it's telling me is that when my x is -3, my y value is 6. Okay, and when my x is -2, over here, my y value is 5. -1 is going to be 4, and 0 is going to be 3. Okay, let's look at what 1 is. The absolute value of 1 minus 3 is the absolute value of -2, or 2. That's here. The absolute value of 2 minus 3 is the absolute value of -1, which is just simply 1. And the absolute value of 3 minus 3 is the absolute value of 0, which is 0. Oh, this is interesting. What I have just done, if you continue going, the absolute value of 4 is going to be 1, and 5 is going to be 2. I have just taken this graph and shifted it over. So by subtracting 3 of an absolute value, I end up shifting my graph to the right with a -3. That's so interesting. So what do you think is going to happen if I add 3? Well, hopefully you can predict that it shifts to the left. Let's prove that. If I take -3, the absolute value of -3 plus 3 is the absolute value of 0, which is just simply 0. So when x is -3, my y is 0. Now, the absolute value of -2 plus 3 is 1, because the absolute value of 1 is 1. And the absolute value of -1 plus 3 is the absolute value of 2, which is just simply 2. And the absolute value of 0 is going to be 3. And 1 is going to be 4. And 2 is going to be 5. And if I plugged in -5, -5 plus 3 is the absolute value of -2, which is simply 2. So I end up shifting my graph to the left. It is the exact same thing as this black one. It's just did the opposite way. You're fine. Come on in. So when I add something inside my absolute value sign to x, it shifts left. When I subtract something from x in my absolute value signs, it shifts my absolute value graph to the right. This is sometimes a little bit counterintuitive. Go ahead and graph these 3 equations here on the bottom, and I will see you in class.